Okay, in this one, I'm going to go into some of the extended features of the firmware. So we go up here to extended, and here we can set the general purpose output ports. Now, if we use the standard outputs on the interface PNP without an I/O board or anything like that, we have 6 that are available, and that's if we're running wasted spark cool-on plug. If we run true sequential coal-on plug batch fire, then we have 4 left over. If we run sequential fuel and sequential ignition, we've got 2 left over. So you have to decide what you're going to do. Don't let the limitations of only having 2 outputs scare you from running sequential or cool-on plug, though, because you can always add an I/O extender board and have 12 outputs on that board alone. So no problem there with outputs. But for this the standard board, all you do is you click on the port that you want to enable, click enable, turns the dot green, and we'll come over here and we'll put 1s in because we want to turn it on when it comes on. And say you want that output to come on under the throttle. We can put 10% there, and now this output will turn on when the throttle percent goes over 10. And we don't know if it works until you actually hook your output wire to the pin, hook a light or solenoid or whatever you're going to turn off and on. There's no indicator in the software that tells that it's turning off and on. But the best practice is to set your output, hit burn, turn the power off, turn the power back on, and now you can test that port. And you can just test it, just turn your throttle over 10%, and that output should turn on. Turn it under 10% and it should turn off. And you can see another thing that here I'll show you while I'm doing that. I selected F idle and I'll hit burn. I'll turn the power off, turn it back on. And if this comes up, there's a light down here that says configuration error. Basically, this means that output right there, F idle, is being used for something. In this test rig here I've got on the bench, where I'm actually using F idle for attack output. So if that ever pops up on the engine speed, you know you got a configuration error. You just straighten it out, and you can tell also turn it off, turn it back on. We've got the configuration error. You can go to communications, hit mini terminal. Make sure that it's set to ASC2, baud rate 115200, and whatever COM port you're using. Turn the power off, turn the power back on, and it'll tell you what the problem was. Conflict with tacho output. Let me go in here and turn this back off. Of course, now we're back to go. But you can set those up as anything. Any of these variables in this window here, you can set to control that output. You can have a second condition, turn it on or off, also as or and. So you could set a window switch for nitrous, say, you have RPM greater than a certain 4,000 RPM and 10% throttle, and that output will come on. So there's a bunch of ways to set it up. You have your manifold air temperature based timing retard. This is real good for turbo bikes running pump fuel. You can pull ignition timing by manifold air temperature. This helps to keep down detonation. This is just the standard map that's already in there. Of course, you would want to adjust it for your own settings, but it's there. And we have the manifold air temperature correction table, and this is a fuel correction table. It's zeroed out right now because the standard fuel correction is in the firmware, and you can adjust that correction here, depending on what your motor likes. It may need no correction other than what's in there from the get-go, but if it does need any adjustments, you can adjust it here. We have launch control. This is another one that a lot of people ask about. The first number here is the launch retard above RPM. What this is when it meets this RPM set point here, it retards the ignition timing to this degree. So I will hit the button. When it reaches the set point, and it will go and retard the ignition timing. When I let go of the button, of course, it'll shut off. Hit it again, you see it goes back to that. You can also add additional fuel. You can see the pulse width down here. We're adding 1 millisecond of pulse width to that. You can set the limiter method, and that is active when it reaches the top number here. So when it goes past 4,000 RPM, it actually goes into a spark cut that we have selected here. And you can set the cut X from Y events. You can set these. You can change these numbers to basically tailor how it's going to cut. So you can change them, move them around. You can make it 7 from 7 and try it, 10 from 10, 5 from 7, whatever. But just change it around and get the style of cut that you want. Of course, this is your throttle percentage. Launch boost target I'll go into when I explain the boost control stuff, so I won't explain it here. But that's pretty much it for the launch control. And you can, on a turbo bike, you can build 10-15 pounds of boost no problem if you want to get violent enough with it. But really, anything over 4, 5, 6 pounds is plenty coming out of the hole anyway. So and you can set it up however you like. But that's pretty much it for the launch control. Time retard by gear. You can set this to pull out a certain amount of degree for each gear. Just 2D table and pull the dots wherever. And I'll simulate the gear range and watch the ignition advance gauge either here or down there. You'll see it switch. But I added that because some guys want to have retard for each gear. Gear sensor setup. This is to set up the GPS sensor, the stock Suzuki gear position sensor. Basically, these are windows. The ADC voltage needs to fall in between these two windows. So you would right-click on the screen. We can add a gauge. Come over here. We can assign this to ADC 7. We can see right now it's reading 34, but say we put it in gear and it was at 370 in first gear, then that would fall in between 350 and 380. So basically, you'd put it on the bike, click it into gear, find out what your ADC is for each one, try to set these windows so it catches each gear. Now, the standard base map that comes in it will have all of these voltages in there. That should work with the stock Suzuki gear position sensor. It's worked on everyone so far, so more than likely, if you have to adjust it, it's going to be very, very minor. But that's how you do set it up. Bike shift cut. This is the air shifter control. You can set it for button mode or auto mode. You set it for auto mode, you have one set target down here for your RPM, for your auto shift point. If you put it to gear mode, you have a shift point for each gear. You put it in button mode, of course, you just have your button input as the source to shift. These numbers should be 0.0. Okay, RPM is at 8,000 RPM, meaning anything below 8,000 the air shifter will not activate. Anything below 70 TPS will not activate. If you want to change these numbers, you can change them to whatever. Delay before spark cut. This is the amount of time it waits before it actually kills the ignition when you push the button. So you push the button, it activates the air shifter solenoid. Then 20 milliseconds later, it activates the actual ignition kill and the spark cut. The minimum you can set for the delay is 20 milliseconds. It's set in the firmware that you can't go any lower than that, the way I wrote the software. Even if you have the solenoid mounted right at the ram, 20 milliseconds is plenty fine. It's super smooth. It goes right into gear, so you shouldn't have no problems with setting it at 20, and you can increase that if your solenoid is farther away from the shifter ram. In gear-based mode, we've got kill times for each gear, and how you set that is you set your spark cut time at your base number. So the shortest amount of time that you want for any particular gear is what you'll set this number. So if you wanted, if the shortest amount of kill that you needed for a certain gear is 60 milliseconds, set that number to 60 and add the additional that you need for the other gear. So if first to second needs 80 milliseconds of kill time, put 20 there, and now you have 60 plus 20 is 80 milliseconds. If you put zeros in there, it just uses the base kill time. It's pretty easy to set up. But for some of the high horsepower turbo bikes, they need a little bit more kill in some of the upper gears and maybe not so much in the lower gears. And you may need different kill times for each gear to actually get it to go into gear. So it's good to have where you can pick each gear's kill time individually. If you put it in just simple mode, it just has one kill time, your base kill time for all gears, and that's it. It doesn't look at your gear position sensor at all. Another thing about gear-based mode is the air shifter will not activate unless it's actually in gear. It has to be in first, second, third, fourth, or fifth. It will not work if it's in neutral, and it will not work if it's in sixth gear. Once it actually sees sixth gear, the air shifter function quits until it sees fifth, fourth, third, second, or first. So it's kind of another added safety thing. If the bike's setting in neutral, it can't automatically just kick into gear. You can pick how it cuts, either ignition or fuel. Ignition and fuel works really clean. There's really no backfire or spitting or sputtering or anything. It's a real nice clean cut. But that's pretty much it for the air shifter.